If you are interested in algo trading, feel free to subscribe to this channel and join our Discord group to exchange ideas. And now let's move to the main topic of this video, which is me sharing my journey on building proper software for latency, arbitrage, algo trading. So let's see when we stopped last time. In the previous video, I recoded entire FXbox app. I made it cross-platform for Windows and macOS. The entire front end was redesigned. I also made some tests to check the connection interface of brokers and exchanges. There was a very big progress in quality of code and the architecture, but one issue was still there. The issue was the throughput of market data. Okay, so at that point I was very proud of this version of FXbox, but still I had some issues with designs and code structures regarding the low latency async programming. So in order to fix it properly for the last time, I decided to decently, and I mean very decently, research the low latency principles in the high frequency trading world. So I started to digging, watching, reading papers, and I learned many useful things during this research, like FIX protocol was the industry standard for communication, but now looks like there is so-called SBE method, which is just a simple binary encoding. So the simple binary encoding outperforms the FIX protocol and should be used for the communication between systems where low latency is crucial. What I also found was that when it comes to low latency in matching engines, LMAX Exchange did the best job with their LMAX disruptor library designed to create new real-time systems. So the core concept of their disruptor library are async tasks on circular buffers. So the project was based in Java, but there is also a port from Java project to open source .NET project on GitHub. So hopefully this helps us a lot. And another thing I found was that there is a common approach to split entire trading systems across many machines to separate the business logic. So for example, just to give you a small look, on one machine, let's say you have a software connected to only one external exchange that will stream the market data. So only one thread would be used, like a hardcore thread wait spin function. Then on another machine, you would have your algo trading logic that would only receive market data from the first machine and execute signals for trades for selected tickers, then another algo machine for another set of tickers, and so on. So let's say you would have one machine to stream market data of currencies, and then you would have on another machine algos to only trade on Euro USD. On another machine you would have another algos to trade only BTC, and so on. So with this approach you separate the volume of the data across different machines to get some better latencies, as you do not want to refresh all the algos on every ticker. The main idea of this approach is to reduce the latency as you split the queue of incoming market data. So when I was browsing the repository, I found those designs that I made. When I was browsing my old documentation folders, I found these diagrams, so maybe I can show you, that are related to this engine software. So low latency HFT framework initialization procedure. So what I can see, these are different machines. So the machine with the algo strategy, with session strategy, another machine journal just to store the logs. What else do we got? fxbox.agent. So I think that one was responsible for communication with the GUI, with the user interface. And here on the right you can see different messages that's supposed to happen, with the order, like first message create stream to journal. Yeah, you can just pause the video, read this if you're interested. Anyway, if we go further, here I had some, what's that one? High-level architecture. So yeah, basically this is the FXbox communication. The idea was to to create one module that will be responsible for this fast serialization and deserialization of the data using simple binary encoding protocol. And here I think I defined the ports. And here we have the algo software, session software, and also the communication supposed to communicate with the agent software. Okay. So yeah, that was like this. And here we have the hot path. So this is the stuff that I'm telling you from a few videos. The hot path is basically the path that the low latency is very crucial, very critical, and no dynamic allocation to the memory should happen. We should pre-allocate everything to create as low latency as possible during the runtime time. So on the red color you have the hot path. Okay, so this is the project of the engine that I was talking about. So the main folder is of course the SRC, and here we have 4 subfolders. The subfolder where I defined all the models, all the entities, is the proto, and here you can see just a simple service to manage the strategies like start strategy, stop strategy, and the payloads for that service. And when it comes to adapters, you can see the entity of MetaTrader 4 account and the instrument of MetaTrader 4, just for example. And also you can find the service that is responsible for managing the connection to the exchange or broker, in that case to MetaTrader 4 connection. So we got RPC calls like connect, disconnect, subscribe, information, stuff like this. Anyway, so this is the folder where I store all the proto files. And now let's talk a little bit about deserialization. So if I go here to the adapter, as you can see, I created here 5 projects. 4 of them are just responsible for creating the connection to the actual exchange or the broker or for feed, like Rhythmic or MetaTrader 4, 5. Here, when I have the models, basically I define my interface in here, like a connection interface, so basically to manage the connection. So the MetaTrader 4, MetaTrader 5 or other exchange connection will will implement this iConnection adapter. That was the idea at that time. So anyway, what do we have in here in broker? Looks like I wanted to implement IQ option, but that's the topic for another story. And yeah, I have also the repositories in here, like I can see the repository for instruments that is shared across all the modules. So anyway, the connection projects are referencing the models projects, and when we go to the messages, this is the place where I defined all of the serializations that I was talking about. So here you can see the SBE, simple binary encoding. So basically how to handle this is to define all of your models in the XML files. Like here you can see I created the file for MDE and TDE. MDE is market data engine and TDE is trade data engine. So basically I defined all of my entities that are being used across communication between different machines. So we got like new market data level 1 with balance message. What else do we have? Subscribed message, unsubscribed message. So everything is defined in XML file. The same is with trading, like new order, modify order, stuff like this. And then when I defined all of this, there is a tool called SBE tool that is taking those XML files and generating the C# code for this. But I made a little wrapper just to loop in my folder and invoke this SBE tool and generate the files in the clean files in clean structure for me. Anyway, so this is for the SBE. I also was playing around with the FBE, which is fast binary encoding. It's supposed to be very, very similar. Also with the code generation, but I ended up going with the SBE. Anyway, so this is for the messages and stuff like this. So let's now go with the engine. So we have algo engine, broker engine, and I made 4 projects. gRPC service for the algo and broker is the core, the main server where all the business logic is being done, and the sample applications are just applications to test the service. So now let me just show you the broker service, because this is very important. I just have two terminals. Let me just start the service, brokers or gRPC service. So let's try .NET run. And the solution is building, and it's connected, and it's working on the localhost 5001 port. And now let's try the broker sample. And the thing that should happen is basically the broker sample will communicate with the gRPC service and will invoke the functions on our service to connect to the exchange. So let's run .NET run. And as you can see, something is happening, and yes, we have the stream of market data. So I made it like I implemented in each payload the bool flag to define if the message, if the method, the call was successful or not, and if not, also we have the message what happened. So information provided successfully, test adapter connection, test adapter information. So this is the Forex demo account. So I tested also I made also negative tests, like, where is it? Test adapter subscribe, adapter instrument not found, invalid instrument ID. So I think I provided some wrong instrument to just test it out. So yeah, as you can see, I use the sample application to control the gRPC service. And now the same thing is with the algo. So if I go in here, I am already in the correct folders. So let's try the algo service, .NET run, and this is the sample, .NET run, like this. As you can see, the same thing happened in here. So we just send the messages to start the strategies, and basically this one, the algo strategy, the algo gRPC service should receive data from the gRPC service of broker, but looks like something is disconnecting from this TCP session. To be honest, it also was old project, so I don't want to spend much more time on fixing this, as a much more complex solution is already implemented. But anyway, this is how the project looked like. Yeah. Okay, so during that development, I was very not sure, and I mean very not sure about correct simple binary encoding implementation, because at that time I couldn't find any good examples with performance test on the GitHub and on Google. I was even considering to replacing the main TCP connection for gRPC communication during my research. But at some point during playing around with gRPC. But more about this in further implementation in the next episode of the series. I hope you like this video, and if yes, please hit the like button below. If you also like and didn't subscribe, please subscribe to this channel.